All right, guys, we're finishing up the review today. So, because we did 26 yesterday. Questions on 27 or 28, either one of those that y'all want to look at. 27C? So we can do A, B, C. So for A, we're looking at f of -8. So we're going to replace x with -8.
Oh, wait, can you do 28 too?
Okay. Now -8 plus 8. 0. Square root of 0 is 0. So f of -8 is 2. F of 1, so we'd have 1 plus 8. 1 plus 8 is 9. Square root of 9 is 3. 3 plus 2 is 5. Really, on these first two at this point here, we could have plugged all that into the calculator and let it do it for us. Straight numbers, we can just let it calculate it out. And luckily for most of these here, the radical simplified nicely. If it didn't, you could try throwing that into the 30xs instead of the graphing, because it will leave it in simplest radical form. And the last one, we have x minus 8 plus 8 plus 2. Or -8 plus 8 would be 0, leaving us with just the square root of x plus 2. And that doesn't simplify any further. Questions on 27? Are you ready for 28? Now, 28 is a piecewise function. Now, which of these two equations we use depends on the value of x that we have. So the first one we're looking at is f of -1. Now, is -1 less than 0 or greater than or equal to 0? Well, -1 is less than 0. So since it's less than 0 and made this statement true, we're going to be using our 2x plus 1. So we'll say 2 times -1 plus 1. And again, at this point, we can plug it into the calculator. But 2 times -1 is -2. And -2 plus 1 is -1. All right. Let's look at B. This time we're taking f of 0. And again, we look at the two statements. X is greater than 0 or less than 0, or x is greater than or equal to 0. Well, 0 is equal to 0, so the second statement's true, which means I'm using the second equation. We have 2 times 0 plus 2. Well, 2 times 0 is 0, and 0 plus 2 is 2. Last one we have is f of 2. Now, is 2 less than 0 or greater than or equal to 0? So we're using the second equation. We'll have 2 times 2 plus 2. 2 times 2 is 4, and 4 plus 2 is 6. Bless you. So for the piecewise, it just depends on which statement, those inequality statements, the value of x makes true is going to be the one that we use. Questions on this here? So we can look at 29 first. Any rational equation, we're really looking at what's going to make the numerator be 0. Because the only way a fraction can be 0 or equal 0 is if the top is 0. The bottom of the fraction is just going to tell us what our restrictions, what x cannot be. So here, the only way that we can have a 0 is if 3x minus 4 is equal to 0. Another way we can get at that is if I multiply this fraction by 5, well, the 5 and 5 will cancel. And if I do it to one side, I have to do it to the other. And 0 times 5 is, so we're still at 3x minus 4. At this point, we can solve for x by adding 4 to both sides, telling us 3x is equal to 4. Divide both sides by 3, telling us x is 4/3. Questions on this here? For 30, 0 equals x cubed minus x. Whenever we have these higher degree polynomials, x to a power greater than 1, we'll need to get it all on one side. Now this one here we can factor. There is a greatest common factor between x cubed and x, and that's actually just x. So if we factor the x out of x cubed minus x, we get x times x squared minus 1. Now x squared minus 1 will factor. It's our difference of perfect squares, which will be our x plus 1 times x minus 1. And since we do have two or more things multiplied together to equal 0, one of these is going to have to equal 0. Well, the nice one is the first one. It's just x equals 0. For our x plus 1, we would subtract 1 to get x by itself, telling us x is equal to negative 1. And lastly, with our x minus 1, we would add 1 to both sides. Okay, take 3. Nope. All right, there we go. Telling us x is equal to 1. So here x is equal to 1, negative 1, or 0, and we should have 3 solutions because the degree is 3. Questions on any of these so far? X to the fourth minus 2x squared equals 2x squared. Again, whenever we have these higher degree polynomial functions, these exponents 2 and or bigger, first thing we need to do is get it equal to 0. X to the fourth minus 4 x squared is equal to 0. Now here, x to the fourth minus 4x squared does have a greatest common factor of x squared. So we can factor the x squared out. And since we have two things multiplied together to equal 0, one of these is going to be 0. Now, x squared minus 4 is a difference of perfect squares. We can factor just like we did previously with our x squared minus 1 and get to this answer. I want to show you a different way. Because since it is a difference of perfect squares, or we don't have a middle term, we can actually solve this by the square root method. We add 4 to both sides, telling us x squared is equal to 4. At this point here, we can take square root of both sides, because the square root of our x squared is x, is equal to plus or minus the square root of 4, which is 2. Because the square root method will work on this here, x squared minus 4. Even if it was x squared plus 4, we can still use the square root method. The only main stipulation with the square root method is we don't have a middle term, a term with just x to the first power. If it was x squared plus 4, then it would be plus or minus 2i, because when we take the square root of a negative, the negative comes out as I. Now, interestingly enough, x squared equals 0. Well, it's really telling me that x times x is 0. That means either x is equal to 0 or x is equal to 0. It has 2 zeros at that location. Questions on 31? 32. We have a quadratic, so we need this equation equal to what? 0, okay? The minus 5x from both sides and minus 19. That'll tell us that we have x squared minus 3x minus 18 is equal to 0. Make sure I got minus 3x. Yep. Here I graphed it. Because again, we're looking for what values of x will make the y value be 0. So negative 3 and 6. Because if the solutions are nice numbers, we can actually find it by graphing x to the 4th minus 4x squared. We do see that we're having zeros at negative 2, 2, and 0. Whenever the graph does cross, or touch the x-axis but does not cross it, so they're at 0, 0, it means that that 0 is repeated an even number of times. It mainly works with higher degree polynomial functions. Questions on these here? Two x squared minus 7x minus 30. Well, we know one of the values is 6. It didn't give us both of the values. So if it gives you one but not the other, there's a good chance that it is factorable, but it's just not that both of them are integers. Since the third term is negative, our signs are opposite. Factors of 2x squared, well, we have 2x and x. Factors of 30, 1 and 30, 2 and 15, 3 and 10. 4 doesn't work, but 5 and 6. Which set of factors do you think we're going to try? Well, we did get a solution, yes? We got a solution 6, yes? So what number do we think should probably work? 5 and 6, because 6 is a factor, yes? So 6 is probably going to work. And if we check this here, 2x times negative 6 is negative 12x. 5 times x is plus 5x. Give us negative 7x. Because most likely if we do have a number, an integer answer, it's going to be by itself because we need it to be a solution. So here, x minus 6 equals 0. We add 6 to both sides, telling us x is equal to 6. Well, that's what the graphing calculator told us. So it kind of gave us a hint at what the factors might be. Our other set of solutions is going to come from our 2x plus 5. Here, first thing we can do is subtract 5 from both sides, telling us 2x is equal to negative 5. Lastly, we'll divide by 2, telling us x is negative 5/2. Questions on 33? 34. X squared minus 9x plus 14 over 4x is equal to 0. And again, for this to be equal to 0, the numerator has to be equal to 0. Another way we can get at this is multiply both sides by 4x. Well, 4x and 4x will cancel, and 4x times 0 is 0. Now, the only thing we have to remember with these rational equations is that the denominator cannot be 0. So if we solve this here, x cannot be 0. If we do get a solution of 0 for this here for x, we throw it out because it's an extraneous solution. Now we need to solve this here, x squared minus 9x plus 14. We can try graphing it first. If it doesn't graph, then we can go from there. It does intersect the x-axis at 2 places. Intersects it at 2 and 7. Questions on 33 or 34?
How are you getting there and taking the graph? I always said they were.
Go y equals. Enter. Graph. Because that you have plot 1 turned on. It was trying to plot the information in there, and there's probably nothing there for it to plot, so it was having an issue. All right, 35. Mm-hmm. 35, our radicals, square roots. When we solve radical equations, first thing we need to do is get the radical by itself. So anything outside the radical that's not inside, here we're just trying to get the square root of 2x by itself. So to do that, we're going to add 1 to both sides, telling us that the square root of 2x is equal to 1. Once we get the radical by itself, we're going to put both sides to the nth power. So since we're talking about a square root, we would square both sides. If we were talking about a cubed root, we would cube it. Now here, the square root and square will cancel, leaving us with 2x. 1 squared is 1. Now we don't put plus or minus when we square both sides. We only put it when we take the square root of both sides. And lastly, we have to solve for the value of x. We can divide both sides by 2, telling us x is 1/2. Questions on this here? Questions on any of these equations here? For problem 36 through 37, find the average rate of change. So our average rate of change formula is f of x2 minus f of x1 over x2 minus x1. So f of x2, we're going to take this x2 value of 4 and plug it into our f of x. So we'd have negative 6 times 4 cubed minus 7 times 4 plus 15. So for here, this is our f of 4, our x2 value. And we're going to subtract from it our f of x1, which for us here would be f of negative 2. So we'd have 6 times negative 2 cubed minus 7 times negative 2 plus 15. All over x2 minus x1. Well, x2 is 4, x1 is negative 2. Now at this point here, you can type that entire thing into the calculator and let it do it for you. Because the rest of this, after we get it plugged in, is all calculator work. Because on bottom, the negative is going to make a plus, so we do have 6. 4 cubed, 64. 28 plus 5. 8. 14 plus 15. I mean 64 times 6.
Plus 5 or plus
15. Yes, that was going to throw everything off. 4 carry the 2, negative 384 minus 13 minus this here would be 48 plus 29 negative 397 minus 77 over 6. 4 carry the 1, 7, negative 474 over 6. Yep. Negative 42. Average change should be negative 79. I think I'll check the answer key to make sure if you want. I think that's it.
negative 79.
Mm-hmm. Yes. Questions on how we do the average rate of change?
This long process later.
Yeah. F plus g of x, f minus g of x, f times g of x, f divided by g of x. We'll look at 38. We're going to start off with f plus g of x. So f plus g of x is the same as f of x plus g of x. Well, f of x in our case is 3x plus 1. G of x is x squared minus 16. At this point, we can drop the parentheses. And then we're going to combine like terms, giving us x squared plus 3x minus 15. Thank you. Yes. Yes. Yeah. So we drop the parentheses and combine like terms. Questions on how we added the two together. Subtracting is going to be similar. But instead of adding them, we're going to subtract them. So the first set, 3x plus 1 is going to be the same. And we got to distribute our negative through g of x. So it's going to become negative x squared plus 16. So now when we combine like terms, we find that f minus g of x is going to be negative x squared plus 3x plus 17.
I think that's where I was struggling on my homework, because I got the entire thing done except for like these.
Yep, distribute the negative through. Combine like terms. Questions on our addition or subtraction? We ready for multiplication? F times g of x is the same as f of x times g of x. Well, f of x is going to be 3x plus 1. G of x is x squared minus 16. And at this point here, we're going to multiply it out. So 3x times x squared, 3x cubed. 3x times negative 16 is going to be negative 48x. And then we'll do the same thing with 1. 1 times x squared is x squared. 1 times negative 16 is negative 16. F of x divided by g of x. There's nothing in common on top and bottom, so 3x plus 1 over x squared minus 16 is as simplified as it gets. I mean, the only way it would simplify is if the numerator was x plus 2 or x minus 2 or sorry, not 2, x plus 4 or x minus 4 or x squared minus 16. Yep, because most of the ones we have, it's just put the functions on top of each other, you're done. I'm not going to worry about evaluating. I'm not going to ask you to evaluate them. Just going to ask you to find the f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Questions on those there? There won't be one like 39. It's mainly going to be like this. So do we feel good with 38? All right, we're going to look at f of g of x, and g of f of x. F of g of x is the same as saying f of g of x. These are the same notation. And with these composite functions, we always work from the inside out. So we're going to start with g of x, which is x plus 7. But now we don't have f of x anymore. We have f of x plus 7. So every x at x plus 7, or every x in this negative 4x, this x here has to be replaced with x plus 7. So we still have the negative 4, but instead of x, we have x plus 7. Questions on this here? Now we do need to distribute. Negative 4 times x is negative 4x. Negative 4 times 7 is negative 28. So f of g of x is negative 4x minus 28. G of f of x. Now f of x was negative 4x, because since it's just f of x, we can replace it with its function. Now at this point here, I need to plug negative 4x into every x in g of x. No, nothing's in front of our x, so we can just drop the parentheses and we have this here. Questions on this here? Find the inverse of each function. So to find the inverse, the first thing we do is replace f of x with y. Then we switch x and y, and then solve for y. So here the first thing we're going to do is subtract 1, telling us 3y is equal to x minus 1. And lastly, we'll divide by 3, telling us y is equal to x minus 1 over 3. Or another way to write it is saying that f inverse of x is equal to x minus 1 over 3. Questions on 42. 43 does have an inverse because we restricted the domain to be greater than or equal to 0. Incidentally enough, the range is actually greater than or equal to 2, which means all of our values will be indeed positive. And we can follow the same steps. We replace f of x with y. Switch x and y. Solve for x. So just like the last one here, we can do a similar method. We can subtract 2 from both sides. Tell me y squared is equal to x minus 2. Now to get y by itself, we'll square root both sides, telling us y is equal to the square root of x minus 2. Now normally we would put the plus or minus in front of it. Now since we said the domain of the original function was greater than 0 or positive, and it works out that its range is positive, when we find the inverse, these flip, but our domain and range for either one is still going to be positive, which means we're going to look at the positive case telling us f inverse of x is equal to the square root of x minus 2. Questions on these here? All right, we'll stop here.